Hello everybody! This is the first video on my channel, my new channel, which is gonna be Physics Sensei. This is my physics channel. Now initially I started off with math, and I will leave a link to the other channel in the description. But today is gonna be a milestone where we start our physics channel. And for those of you wondering, yes, I will still do math videos, but I will also do physics videos. So we have more of a variety, and I wanted to explore this for a long time. Now if you see here, I'm using a whiteboard like I used to do before I switched to presentations. And I'm actually planning to switch to this from the presentations because this is actually easier and it's more powerful, more functional, looks cleaner and everything than the presentations. As soon as probably in a few months, I'll probably switch my math videos to this also, but for now, the physics videos will also be here. Today's physics video is about basic physics terminology and all the different things associated with it. So, the first thing that we're gonna do is we're gonna talk about the basic of the basics. So, let's start with position. Let's say we draw a line in the coordinate plane. So let's say we have a line across this axis over here. Then after that, let's say we have a position. Let's say this is 0, this position is -1, and there's a +1. Basically, it's where it is in respective to a point called the origin. Sometimes we will have position functions like x of time. All functions in physics are pretty much always related to time. So x of t, let's say it's equal to t squared plus 2t plus 1. So from that we would find velocity and acceleration. Now, for now, I'll be covering algebra-based physics, not calculus-based physics, since we're not done with our calculus unit and math. So when we get finished with that, then I will also evolve into calculus-based physics. So that's position. Velocity is if we take the position and divide it by time. Now in reality, it is a quantity called the displacement divided by time. The change in position. So yeah, that would be displacement. It's not position. Displacement, which is also known as x. I'll just put delta x over here to represent the displacement over time. Now, displacement is basically the shortest path from one point to another. So let's say we have this very crude circular track, and we start over here, put this in purple, then we go halfway across the circle. The displacement is this distance. But what if we draw this dot again and we go all the way around the circle? Now it's 0 because the initial point and the final point is the same. The distance though is 2 pi times the radius of the circle. The next thing we're going to be talking about is acceleration. So acceleration of t, or we're just going to call this a, is equal to velocity over time. Now, as you see, it's like x of t, so position, velocity, then acceleration is velocity over time. Now, I just want to take a quick second. It's pretty simple to understand acceleration, and I just wanted to take a quick second to talk about units. For these three quantities, position, x is in meters, v is in meters per second, and acceleration is in meters per second squared. Now, let's move on to dynamics and talk about another thing, force. Force, according to Newton's second law, which we'll cover later, is equal to mass times acceleration. Now, mass times acceleration is just mass times acceleration. Now, before we talk about force a little more and the units, let's talk about mass. Mass and weight are not the same thing. Mass is an intrinsic property of an object, but weight depends on where it is, which planet it is, whether it's close to a star, how close it is to it, and it varies. But mass is a fundamental quantity that cannot be changed, and often we represent this in kilograms. So, force, or F, would be mass times acceleration, so kilograms multiplied by meters per second squared. But this is equal to the Newton, or just M. So these are some of the very basic physics terminology. Now let's get into stuff a little more advanced. Now it's not really that advanced, that is extremely difficult, but it's just, we'll cover most of the stuff later, actually covering it. For now, we're just going to introduce the terms. So the next term I want to introduce to you guys is a concept called friction and the coefficient of friction. So friction, there are two types of friction. One type is static friction. The other is kinetic friction. Now, static and kinetic, we won't talk about the formulas over here, but overall, pretty much always, the maximum static friction, or we can represent that by, we can say force of friction, so we can say static, we can say S maximum is always greater than K, or the kinetic friction. Now the thing what I'm saying is S maximum is because static, let's say the maximum force of static friction on an object is 20 newtons, but an object is only pulling at 10 newtons. That means the static friction would be equal to 10 newtons, not 20, because static friction can take up any amount that's under its maximum, and how you calculate that maximum is for another day. The next thing that we're going to cover is energy, like work, potential energy, and kinetic energy. So what we have is, first we have work. Not like the work like, oh my, I did so much work in school today. Oh, so much homework. Not like that. The physics definition of work is equal to force multiplied by distance multiplied by the cosine of the angle between the displacement and the force. So that's work. Now, potential energy is different. Now, there are multiple types of potential energy, and it's represented by U. So U, there can be gravitational potential energy, MGH, elastic potential energy, and so on. But all you need to know, another thing that you need to know, not all you need to know, is that normally potential energy is equal to the negative of the work done. Now, kinetic energy is the energy of motion and is often represented with K. And normally that's equal to 1/2 times mass times velocity squared. So that's pretty much all there is for energy. The next thing that we're going to cover is momentum. Not like the browser extension you might have seen online. Momentum is the product of mass times velocity, or another way to write it is the derivative of momentum with respect to time is equal to force. But that's not really needed right now since we're not done with the calculus series on my main channel. So momentum is mass times velocity. And another key thing about momentum is the conservation of momentum. So let's say we have let's say we have two masses, M1 and M2, with two different speeds coming towards each other. That means the sum of their momentum is equal to m1 times the final speed plus m2 times the final speed. This is always true no matter what happens. This will always be the case, but that doesn't mean all kinetic energy is conserved, and that's where we get into the different types of collisions, but those are not important as of now. What is important though is talking about rotation. Before I talk about rotation, before I talk about the acceleration, what happens is the acceleration is always pointed towards the center, so perpendicular to the velocity, almost wherever it is. That's centripetal acceleration. Then, with every acceleration, there is a force. So, this is also a force towards the center of the circle. That's what centripetal and acceleration and force are. The next thing is the law of gravitation, where there's a basic constant g, where g is equal to about 6.67. Don't go in the comments saying 6.7. Please, I've had enough of that. Multiplied by 10 to the power of negative 11 times, I'm not exactly sure what the units are, I'll have to check, but this is what I do remember. Now we can finally talk about rotation. For all of the quantities mentioned above, they have a rotational analog. For position, we have angular position. For velocity, we have angular velocity. And for acceleration, you guessed it, we have angular acceleration. Instead of force, we have torque. Instead of mass, we have rotational inertia, and so on. The next thing we're going to talk about is springs, but all we need to know is that there's a term called the spring constant K, which basically says how stiff the spring is. I think that's actually about it. That's all the terminology that we're going to be using in mechanics, at least algebra-based mechanics. Not going into much detail, but still just a rough overview of most of the topics. So thank you so much. See you in the next one, and bye-bye.